Okay, so today we are going to talk something about one of the most important modeling techniques in computer designing that we call structure charts using top to down design approach. But before I come to explain this important modeling technique of computer designing, let's have some background information about this topic. So let's suppose you are working in a software house or even working as an individual and you're just trying to make an app or a software application or working on a project. So you will first start by the step of design. And to express the design, there are so many techniques and tools available, but at this stage, and the most important one is algorithm. So at this stage, what we have got to understand and learn is algorithm. And this algorithm can be expressed either in fake code, which we also call as pseudocode, or the graphical representation, which we also call as flowchart. And after that, this whole design step will be converted into some high level language code, or you can say programming language code. Just like we have C, Visual Basic, Python, Delphi, or it could be Pascal. But the chosen ones are C, VB, and Python. Nobody bothered nowadays to program in Delphi and in Pascal because they are obsolete now and they have no practical implementation. So among these three languages, Python is the best, but we teachers normally prefer to program in C and Visual Basic. Why? Because they are nearer to the syntax of pseudocode, or you can say that it is easier to convert your design into the code of these languages, C and Visual Basic. This phenomenon is also called as transferable skills. So whenever we are going to make a software or an app, first we have to write down these things on the paper, like what would be the input, what variables will I be going to use, and how the values in these variables will be stored, and how the output will be generated. These are all the steps that we discuss at design stage, and later on this design will be converted into any of our chosen language code. So this is the whole phenomena of programming. Okay, when we talk about writing the pseudocode or making or drawing a flowchart, there is another important modeling technique that we call structure chart. And this structure chart is inspired by a concept that we call top to down approach or top to down design. Okay. And this is so important concept that normally it is applied first, even before making the pseudocode or making the flowchart. So this is very important modeling technique in software designing. So the main idea behind this top to down approach or top to down design is to divide the bigger software or bigger problem into subcategories. that in the programming language vocabulary we call modules. So this is the main idea behind top-to-down approach, is to break down your bigger problem into subcategories or subproblems that we call submodules, or even in some languages these are called functions. Okay. So if you have a bigger set of instructions or a big software, you should divide into subcategories or sub modules, so that these modules will perform their own work and so on. So for instance, uh, let's take the example of the software at Imtiaz Superstore, or you can say Walmart. So what do you think, what kind of software they are running on their systems or checkout counters? So that software will probably be going to take input from barcodes via different scanners, and then it will do some calculations or totaling on that input, and after that it will produce some final list on the screen. So these are the examples of a small program. So these are small programs. So instead of writing a big module at one place, we can divide this whole big module into small programs. Okay, so this is the concept of top-to-down approach. And to combine all these small programs, we have a main module that can join all these small programs, get together to work as a single unit. Okay, so this is the concept of top-to-down approach, is to break down your bigger problem. Instead of writing the whole program at one place, divide it into smaller manageable programs, and to combine these small programs by a main module. Okay, now let's have a look on a program that is when the top to down module is converted, or when a structure chart is converted into a program, how it looks like. So here you can see that this is the main module, which joins all the other submodules of the program. So it starts with main, and from this main module, all the submodules like append, read, add, delete, edit, search, these are the submodules, are called from this main modules. So, and these submodules are defined here, just like I have given here two such submodules like append and read. So this is how the structure chart or a top-to-down design is converted into a program. So here you can see that the submodules are defined separately to perform their work, and this main modules combine and join all these submodules of the program. Okay. Now let's summarize all of this top-to-down design like this. Top-to-down design is the breaking down of a computer system into a set of subsystems that we call submodules, then breaking each subsystem down into a set of smaller subsystems until each subsystem just performs a single action. So this is how top to down design can be defined. And furthermore, we can say that this is an effective way of designing a computer system to provide a solution to a problem. So this approach is also called as divide and conquer approach, since each part of the problem is broken down into smaller, more manageable problems. And let me also tell you that this process of breaking down into smaller subsystem is also called as stepwise refinement. So this approach is also called as stepwise refinement. This is another term for the same concept, and it can also be called as the decomposition, because in this approach we decompose a bigger problem into some manageable small programs. Okay, and what are the benefits of this approach? The first one is obviously this approach is simple to understand. If you break down a bigger problem into sub-problems, then it is simple to understand. And there are some other benefits as well, like reusability of the code. Reusability of the code means that once a code is defined, it can be redefined, it can be reused again and again. So there is no need to define that submodule again and again. Just like here, as you can see in this program, the append function is called once. So whenever this submodule is called, the control will transfer to this submodule, and we can call this append module as many times as we want. But we don't have to redefine this append module again and again. Once we have defined this submodule at one place, we can call it many times. So this is called reusability of the code. Then efficient debugging. That is, it is easier to remove bugs or errors in a program using this approach. It is very easy to find if I know that the problem arises from this submodule, so I will check only this submodule. I will not bother to check the error in this submodule or main module. I will just restrict myself to this submodule. So it is very easier to remove errors by following this approach. Now, also note down some of the terminologies that is associated with structure charts. Now, as you can see in this diagram, the top layer of this structure chart, which contains the main module, is also called as level 0. So the first layer of the structure chart, which contains the main module, is called as level 0. And the layer below this main modules, which contains the sub-modules of which are called by this main module, this layer of structure chart is called as level 1. And furthermore, if we have another layer after this level 1, then that layer will be called as level 2, and so on. So these are the terminologies associated with the layers of the structure chart. The top layer called as level 0, then level 1, then level 2, and so on. Okay. And there is another term, interface. Interface means that when a submodule is called by the main module, this calling of submodule by the main module is called as interface. Okay. So here you can see that the main module is calling submodule A and submodule B. So there will be this main module will make the use of interface when it will call these submodules. And also note down that when a main module or when the higher level module call a lower level module, then there can be some data transfer between these module and some module. Like here, you can see that a value is passed by the main module to the submodule A. This is represented by A. So in this case, main module is calling the submodule A and give it a value A. And submodule then process this value A and returns back the result in the form of value X to the main module. So this transfer of data, values of this transfer of data are called as parameters, or we can also call as data couples. So when a main module calls a submodules, there can be one or more data values passed between these main module and submodule. Okay, but it is not necessary to pass a value, but in some cases there can be one or more value passed between these modules. So these values are called as data couples or parameters. And here you can see that the submodule A returns back the result in the form of value X to the main module, and then main will send this X value to another submodule, this is called B, and so on. Okay, so these are called parameters or data couples. The values that are passed between the modules are called as parameters or data couples. And we use when a higher level module sends a value to the submodule, we use this symbol. And when a submodule returns some value to the main module, it is represented by this symbol. Okay. And now we have another term that is called as sequence of execution. By sequence of execution, it means that always whenever there is no specific way of order is specified, always the sequence of execution will start from left to right. So here you can see that the main module will first call submodule A because it is on the left hand side, and then it will call submodule B. So whenever the sequence is not explicitly given, we follow this default sequence of execution. That is, the left side is always executed first before the right side. So this is some basic terminology associated with structure charts. And even we have some advanced terminologies as well that you can see here. You can read it for your information, for your knowledge. So these are the terminologies associated with structure chart.